Hello everybody, welcome to eGreen Academy's Solar Energy course. It's an online course where we will be covering first 4 modules at this point of time. So, our first module is Overview and Outlook for Solar Power. Before starting this session, I will just give you a brief about our organization called Neutrino Energy. So we are a multidisciplinary organization which provides renewable energy capacity building, corporate social responsibility advisory and implementation, renewable energy services. We have been represented, recognized and acknowledged across the world with the common purpose of sustainable energy for all. Our main motto is Go Renewables. Your neighbors will think you did it for environment, but you know that you did it to save your money. Some of the awards and recognitions from Harvard University: Young Leaders Debate, Nudge Global Leadership Challenge, the Climate Reality Project, Ministry of Gender Equality and Youth Affairs from Korea, and Waka Waka, solar energy company from Netherlands and working in West Africa. So let's talk about what are the global energy trends and challenges. First is population. Of course, the population is growing in a very tremendous manner. Hence, as population grows, your electricity demands again increases everywhere. Security. You have the various energy security challenges, like in terms of availability. Is energy available for me a long time? That is question for me. Is energy affordable for me? Because there are lots of poor people who are again do not have access to electricity. So there are heightened concerns about security. Environment. Again, you need to balance environment and your needs in the same manner, because if you are using or consuming the more amount of electricity from conventional source of electricity, you would be harming environment, thereby raising a great decisions for tomorrow. So this is all about global energy trends and challenges. So what are the different energy challenges that the world is facing right now? The world population is expanding rapidly and we'd like to reach over 9 billion before stabilizing. Again, energy use is directly proportional to the standard of living, because as your standard of living increases, as you want more devices, electrical devices, you need more energy use. And your energy demand is almost skyrocketing, because as the people and the population is increasing, demand is very much increasing at a faster rate. First is standard methods of producing energy have a limited supply, such as coal, gas, oil. These are the very finite energy sources which can deplenish at any amount of time, at any point of time, and at any instant where you cannot imagine, and they have unexpected impacts on the environment, such as global warming, carbon emissions, climate change. What is the consequential impacts? Is the reason behind it? Conventional energy. One of the most important global challenge that the world is facing today is there are 7 billion people live on earth today, and out of that 7 billion people, only 2.5 billion people do not have access to electricity. Look at the amount of people that do not have access to electricity. One of the important concern in the world is like 2.8 billion people lives in areas where there is a high water distress. Again, there are two sources of energy. One is electricity and water, very much scarce. Talking about the global energy scenario, in today's there are about 31%, almost 31% of the energy comes from the coal, and almost 60% energy comes from the conventional energy sources, 60 to 70%. Only, if you can see here, only 18% of energy is coming from renewable energy sources. But if you take up the situation in 2020, almost 32% of energy would come from renewables. Let's talk about the targets. I don't know whether it will be fulfilled or not, but we need to take an action against it. Talking more about the country specific, I'll be talking more about the India's. What is the India's energy crisis? 136% growth in India's energy consumption. More of a positive sign, renewables will grow from 2014 to 2035 with a 6.5 times. Coal consumption, one of the largest in the world, 435 million tons of oil equivalent. Can you imagine? One of the biggest increased in the coal consumption in the world. And of course, the impact is CO2 emissions from energy use rise by 122%. This is the number that we need to hit upon. Now, India has a crippling and unsustainable energy deficit. If you want to have more demand, you need to add 450 gigawatts of energy in the next 20 years. And how can we meet that demand? If we can look upon the history of this 5-year plans, you can see the orange ones are your targets and how much you have made, that is instincted in the blue color. So if you compare the target and achievement, it's nowhere. Then how this demand will be fulfilled? Talking about the oil and coal supply, almost 80% of oil which we are currently importing from the rest of the countries. 72% of the coal we are importing. If this is the case, then what is the situation in case of energy security? Where will be having the energy to be made available for this kind of a people and to meet this kind of a huge demand? This is the energy crisis. What is the another energy crisis? We have the lowest per capita energy consumption. Talking about any other developing countries, US, Germany, China, Iran, Brazil, Mexico. India has a very less 672 per unit per capita energy consumption. Very less. Grid outages, if you talk about the grid outages, the upper north is one of the most suffering states, and southern region and northeastern region, these are the most suffering states from the grid outages, almost more than 30 hours per week. Again, this is one of the greatest example of energy crisis. We have been consuming energy at an alarming rate. If we go by 2036, there will be a compound annual growth rate of 3% every year that we need to take up for energy consumption. But how can the energy consumption would be lesser? And almost the reason would be, or the solution will be like lowering down the cost of energy. But if you consider the tariff, industrial electricity tariff between India and Germany, almost 6 cents is in Germany and 10 cents in India. Huge. Again, 50% of India's rural population, almost around nearly 80 million households, does not have electricity. One of the biggest problem in India. So what are the different possible solutions I bring along with this kind of energy crisis? So first of all, implementing renewable energy sources. Talking about the wind, solar, hydro, these are the renewable energy sources that we need to cater out, and we need to put the tap on the potential which hasn't been explored yet. We need to tap that potential at a very much extent. Energy efficiency, reducing the energy demand from the last mile applications such as tube lights, fans. Use them whenever it is necessary. Use the energy efficient appliances. Lighting controls, again controlling the lightings, controlling the illumination, controlling the street lights, controlling the various kinds of lighting loads. Reducing the energy demand, use energy whenever it is necessary. Enhancing energy security by employing various kinds of new techniques that can lower down the energy consumption. So these are the 5 possible solutions, but we will be only talking about this kind of a solution, renewable energy sources. So what are the different renewable energy sources? Let's talk about the wind energy. Energy getting generated from the wind that drives the turbine and that hits the generator, and then it produces an electricity. Biomass energy, right from the fuel wood, right from the waste material, burning it and rotating the turbine and then producing an electricity. Hydropower, a run of a river, when the flow of a river is coming up at a very high speed, make up a turbine, rotate it and then generate an electricity. Geothermal, take a heat from inside the land and that heat will be used for rotating the turbine and in order to generate an electricity. Ocean energy, ocean has a huge power. Why can't we use it for rotating a turbine in order to generate an electricity? Solar energy, of course everyone knows about it, taking a huge amount of energy from sun and converting it into the electricity. So these are the various kinds of different renewable energy sources which I am talking about. So talking about the different renewable sources, how it is compatible, I have made a comparison of various factors and various renewable energy sources such as solar, wind, picohydro, biodiesel, fuel cells. Fuel cells are the normally which can generate an energy by separating hydrogen and oxygen, and that hydrogen will be stored in a cell in order to provide an electricity. DG set, diesel generator sets. So what are the factors I have considered? Capex, capital expenditure, what is the investment needed? OPEX, how much is the cost to run the operation and maintenance, reliability of that energy source, fuel availability, eco-friendliness, resistance to losses, and overall attractiveness. So I'll just give you a brief understanding. So if the circle is fully filled, that means it is attractive in that perspective. So let's talk about the capex. Capex is very much high in case of solar and wind and DG sets, hence it is half attractive. But in case of hydro and biodiesel, it is very less, so it is highly attractive. But fuel cells are very much expensive, hence it is not filled up. Operation and maintenance cost, that is OPEX. For solar, wind, it is nothing, so hence these are the very much highly attractive sources. Picohydro, biodiesel, DG sets are halfly attractive. Fuel cells again very much expensive in terms of operation and maintenance cost. Reliability, how reliable is the source? As you know that solar is only available in the daytime. Wind is also available in like whenever the wind flow comes in. Picohydro again, it depends upon the water, river flow of water. Biodiesel, it again, I mean if you have the sources of raw material, then it is absolutely available. So these are the kind of a reliability that you can use it anywhere, but here you have to depend upon the natural resources. Fuel availability, solar, sun, abundant source of energy. Wind again abundant, but that is not again reliable in terms of wind speed and other things. Again biodiesel, one of the good, but again raw material will be very difficult in situation. Fuel cell, you cannot have that kind of a thing because separating hydrogen and oxygen from water is very much difficult. Again, in terms of eco-friendliness, these are all the renewable sources of energy, but again DG sets uses a diesel which emits carbon emissions, hence it is totally unattractive. Resistance to losses, picohydro is very much fluid in nature, so it does not take that much amount of losses as compared to the solar, wind and other sources of energy. If you talk about overall attractiveness, solar is one of the biggest attractive source of energy. Second comes wind, third comes picohydro and DG sets, fourth comes biodiesel, and fifth comes fuel cell. So as one of the most important and attractive sources of energy being selected as a solar, we would be focusing more only on solar. So let's talk about solar. What is solar? So solar is how it generates an energy. Basically we need to understand that first. So this is the sun, the burning sun. So it is a mechanism where thermonuclear fusion reactions occurs at the sun and it emits the sun rays. Now what are the different kinds of energy and what are the different kinds of wavelengths, or what are the different kinds of radiations involved in the solar energy? X-rays, ultraviolet, visible light, infrared radiation, microwaves, radio waves, sun's energy spectrum. This is the sun energy spectrum, and these are all the radiations which are available in the sun's energy. So if you talk about the energy of a sun, it is infinite, free to use, of course. Let's talk about one of the biggest thing. Solar emits almost around 174 petawatt of energy. Petawatt, which is like 890 lakhs gigawatt of energy, which is the amount where it can generate energy to power almost 100 Earth. This is the amount of energy that it generates. But almost out of 174 petawatt of energy, almost 89 petawatt of energy is available for energy generation. Almost 47% of the energy. So where does the rest of the energy goes? It reflect in the atmosphere, reflected by clouds, reflected by earth surface, then radiated to space from atmosphere, radiated from space to earth to space. These are all the radiations which are consisting where the rest of the amount of energy which goes away. So this is about the energy potential. So we would be talking about more about the solar photovoltaics. So how does the photovoltaic mechanism works and how it actually generates an energy. Let's talk about the PV cell. So here the blue dot, which represents a location that can accept an electron. Negative is a free electron, positive proton, negative tightly held electron. So there are two layers which are basically in the solar PV cell, N layer and P layer, negative layer and positive layer. So we call it as here negative character and positive character. So negative character is mainly consist of the proton and free electron, and positive character mainly consists of all the three things: negative, free electron, proton, and tightly held electron. Now, what is the next step? This is the basic architecture. Now what is the next step which we are currently working upon? So we have the N layer, P layer. Now we need to form a junction between this N layer and P layer. So we need to provide an electric field from this P layer to N layer to attract the positive and negative charges. So how does it matters for a second? So what we want to do is the free electrons travels from N layer to P layer. So combining with the tightly held proton, tightly held electron and a free electron. So combining this kind of a layer here, when the sun's energy puts it on a negative charge, it automatically attracts the P charge, and hence the PN junction forms. When this energy forms up, the free electrons in the form of energy goes into the load powering the electricity. So this is all about the mechanism, how it works. So it is basically N layer, P layer forming a PN junction, forming a free electron with the positive and the negative electron, which is proton and electron, and then forming up and generating an electricity through free electron, which normally caters to the load. So this is all about the photovoltaic cells. In order to visuality of the photovoltaic cell, it normally views like this. So we have talked about the PV cells. We have talked about what are the different sources of renewable energy sources. Now, how is matters where the sun is exactly located across the country? So where I can generate the energy most, where I can generate the energy and utilize it more. So if you talk about the utilization part, I think northern India, some of the western India and some of the southern India is more capable of having the most radiating zone. But in the current situation, Rajasthan and Gujarat has the biggest installed capacity across India. It's not because of the highest radiation zone, but it also because the policies, it also because the regulations that the country has developed or a state has developed in that respective phenomenon. So western, southern and northern region has the greatest radiation potential. So talking about the different types of solar technology. So there are four types of solar technology I am talking about, and what are the different applications where you can use it. So first one is a grid connected, where you generate an electricity and it is directly supplying an energy to the electricity grid of government company. So directly supplementing to the main supply. Standalone, that means it is not connected to the grid. It is only used for your own purpose. Like if you are using the solar photovoltaic cells and it is generating an electricity, it is not going into the grid, it is going to power your devices such as lighting, radio, TV, and there are lots of other applications where you can use it, like commercial systems, healthcare, hospitals, water pumping, commercial systems, remote settlements, mini grid systems. And the third is a solar thermal. Solar thermal is a kind of a mechanism where you are using the sun's energy to hit the water. And the water, again, there are two types of applications where you can use the heating water, hot water, to use in various kinds of application, or that hot water may be used to rotate the turbine and again and generate an electricity. So these are the two kinds of mechanism where you can use it, like connected to the existing water or space heating system. You can use it as a heating, ventilation and air conditioning control. And this is the use where you can actually implement it more in terms of application. Solar thermal standalone, again standalone system which is normally used for your own purpose, for the hot water appliances or for getting the HVAC needs fulfill in place. So these are the four types of different kinds of solar technology which normally uses the solar as a main phenomenon. So in this module we have talked about various nuances about the solar, how solar came into existence, what are the different kind of parameters are driving the renewable energy market. So how solar look like, how solar energy gets generated, and mainly we talk about the solar energy radiation, where it is exactly placed, how to identify that area. Then we talked about what are the different kinds of technology which are available in solar energy space. So we have talked about all the solar energy outlook. In the next module, we will be looking after the solar design, how exactly solar energy getting generated. So in order to tune up for our next session, module 2, solar energy design and layout. Thank you very much.